This is R.D. Sharma solution, class 12th, chapter 7, adjoint and inverse of a matrix. Exercise is 7.1. Find the inverse of the following matrix and verify that A inverse into A is equal to I3. A inverse we already know how to find out, and we multiplied by A, it should get I3. I3 is nothing but 3 by 3 identity matrix. That means we have a 3 by 3, 3 rows, 3 column, and in the diagonal it will only be 1, else it will be 0. So A inverse you already know how to find it out. Just to recall that these values, every value, the cofactor has to be found out. Once the cofactor are found, then these values are to be placed in the place of the value for which the cofactor has been found. And cofactor will always take the sign, that is minus 1 to the power I plus j. I and j are the row and column. For example, let us take the first one. It will be 4, 3, 3, 4 minus 1 to the power 1 plus 1. So 16 minus 9 is 7 here. And minus 1 to the power I plus j, 1 plus 1 is nothing but 1 minus 1 to the power 2, that is going to be plus 7. So this is how we have achieved 7. All of it you have to do for the 9 values, and then you have to take the transpose of that matrix. Row you have to change to the column. Once it is being done, this is called the adjoint of A. Now you have to divide this adjoint of A by the determinant of A. Determinant of A is 1. So I'm not computing it, just telling you to go through it. The determinant of A will be 1. So A inverse will be adjoint of A divided by determinant of A. So this is the A inverse. Now you have to multiply this A inverse with the actual A which is given in the question. Identity matrix will come. So this question is exactly the previous one we did. The same procedure need to be followed. For the following pair of matrix, verify that AB inverse equals B inverse A inverse. So you see this question, the next question, and the next question, that is this one also. It is one of the part of the what we will do in the this question which I'm talking about. So we'll try to do this question properly so that the next two question gets covered. So AB inverse. First we have to multiply A and B. Then we will take the inverse. Then we will take the B inverse, A inverse, and then we will multiply them. So A into B. So matrix multiplication is the precursor. You need to know it before going ahead with adjoint and inverse. So multiplying these two matrices A and B. So the row has to be multiplied with column. So 3 into 4 plus 2 into 3. Then 3 into 6 plus 2 into 2. This is the first row. Now both columns are done. Now the second row with both the columns. So 7 into 4. Plus 5 into 3, here 7 into 6, plus 5 into 2. Okay, this is the matrix multiplication. This is 12 plus 6, it is going to be 18. 7 4 is a 28, plus 5 3 is a 15. So 28 plus 15 is 3 and 4, 43 it will be. Then the next one, 6 3 is a 18, plus 2 is a 4, 18 plus 4 is 22. 7 6 is 42, plus 5 is 10, it is going to be 52. Now this matrix is simply A into B. We have to take the inverse of this matrix. Inverse is what? First we have to find out the adjoint. So A into B basically it is. By itself it is single matrix, but it was the result of A into B. Adjoint of A you have to replace, or you can say exchange these two values, 18 and 52, and then you have to change the value of minus 22 and minus 43. These sign has to be changed. So this is your adjoint AB, but still we need to find out the inverse. This is the adjoint. Now adjoint AB divided by determinant of AB is going to give you the AB inverse. So 52 into 18 minus 43 into 22. Let me tell you the value. You can compute it, it will be negative 10. I'll give you the answer, it is negative 10. This is the solution on the back side. but let me tell you, it is minus 1, minus 10. So now adjoint AB has to be divided by the determinant of AB. So minus 1 by 10 it will be. So this is your final value. Now coming to the right hand side. In the right hand side, B inverse A inverse has to be computed. I'm going to multiply. So B inverse will be, I'm doing it here only, 4 and 2 has to be exchanged. I'm trying to tell you the 4 and this 4, 2 exchange, 6, 3 same change sign, that is going to be B inverse. So 2 and 4 I have exchanged. The sign I'm changing, minus 6, minus 3. So this is your adjoint B. And what you have to do, multiply it by, this is the determinant, 4 into 2 minus 6 into 3, 8 minus 18 minus 10, so minus 1 by 10, this is going to be the B inverse. Now this is going to be B inverse. Now coming to A inverse. This is 3 into 3 and 5, you need to exchange the places and then change the sign of 7 and 2. So 5 and 3 have exchanged, minus 7 minus 2. So this is the adjoint of A. Now determinant of this will be 5 into 3, 15, minus 7 is 14, it is going to be 1. So it won't affect, even if you divide it by 1, it won't affect. The adjoint of A is actually the A inverse because the determinant is A. Now let us multiply these two, B inverse, A inverse. So I'm multiplying it here, 2 into 5 plus 7, 6, 42. Now 2 into 2 and 6 into 3 along with the sign. Just keep an eye on the sign also. Minus 3 into 5 plus 4 into minus 7. Just take minus because there is already a minus. Okay. Now minus 3 into minus 2. And this is going to be 6 plus 4 is 12. This is going to be 10. 10 plus 42, 52. And this is going to be minus 4. Minus 18, minus 22. Minus 15, minus 28, that is going to be minus 43, and 6 plus 12 is 18. So this is B inverse A inverse, and minus 1 by 10 was already there. If you see, these two are exactly similar, so the equality is verified. So I'm just cleaning it and I'm going to show you the proper result. So if you're doing it in your exam or in your classwork, you have to do exactly like this. Means you have to write everything like we have AB is invertible. You have to check A, B, the determinant also. So this not equal to 0, this has to be find out because the singularity has to be checked, non-singularity has to be checked because this is this comes when the inverse have to be found out. See, this is not equal to 0, this is not equal to 0. These are the basic things you have to do and you have to write all so that the examiner can understand. So as I said, the previous question exactly similar like this. So I hope you will be able to do this in the line of what we have already completed. Okay. So I'm just going ahead and this is one of the part of what we have done earlier. So you can multiply these two, take the inverse and the result is in front of you. Let me tell you that when you take the AB determinant, it is going to be negative 2, so you take the adjoint and divide it by minus 2. Next one is A is given, A inverse, show that this thing. So A inverse, let me just do it. 7, 2 you have to exchange and you have to change the sign of 4 and 3. So it is 3, it is 4. Now divided by the determinant of A. It's going to be 7 is 14 minus 3 4 is 12. So it is going to be 1 by 2. This is going to be your A inverse. So adjoint A we have found out and then divided it by the determinant of A. Now this is 2A inverse. So twice of this, 1 by 2, 7 by 7 and 4, 3 and 2. And 2 gets cancelled. So whatever on the right hand side you should get 7, 3, 4, 2. So let us do it. 9 identity matrix, since it is 2 by 2 matrix, 1 0 0 1 will come minus A. What is A? This is 2 minus 3 minus 4 and 7. So it is going to be scalar multiplication 9 0 0 9. Then you have a subtraction 2 minus 3 minus 4 and 7. Okay. 9 minus 2 is 7, 0 minus of minus 3 is 3, 0 minus of minus 4 is 4, 9 minus 7 is 2. Okay, these two are exactly similar. This is how we have to do it. So how we have to write, this is I'm just giving you an explanation and the logic how we have to do, but this is how you have to do in your examination. These are the steps you have to write now. LHS, RHS has proved this, all you have to write. Okay, this question, you just have to find out A inverse. A is already given, identity is 1001. So you can just put all these value here and just check left hand side is equal to right hand side or not. Okay, so I'm just giving you the idea that 1 and 4 has been exchanged, 5 and 2 the sign has been changed, and the determinant will be 4 minus 5 to the 10 is going to be minus 1 by 6. So this is going to be your A inverse. Put it here and put it at the place of A inverse where you have, and I'll just show you how you have to do it. You can just recheck it once you are done. I encourage not to see the answer before. Now next one is also something like this, but since we don't have numbers, we have A and B, etc. We'll do it. A into A inverse. Let us find out the A inverse. Exchange the diagonal values. So 1 plus BC by A here, and then we will get A here. B and C sign we need to change, minus B minus C. Okay. Now multiply it with A. Multiply this. We have just found out the adjoint, and we have to find out the determinant. So we have to find out the determinant also. A into 1 plus BC by A minus BC. The A gets cancelled. 1 plus BC minus BC it will be. So BC gets cancelled. You get 1. So it won't affect. The adjoint is only the final A inverse, because determinant of A is 1. Now multiply this with A, because we are doing first we'll perform the left hand side and we'll try to equate it with the right hand side. So this is multiplication with A. Let us multiply this with A. 1 plus BC, A gets cancelled. This is going to be minus AB. This is going to be minus AC. This is going to be A squared. This is your left hand side. Now coming to the right hand side, so RHS will be A squared plus BC plus 1 multiplied by identity matrix. You have 1001 minus A into capital A. So multiply it with A and then write it here. A into A is A square, A into B is AB, A into C is AC, A into 1 plus BC by A gets cancelled. You only get 1 plus BC. Okay. Now this is simply a scalar multiplication. The last question we did 9 into I, like that. So A square plus BC plus 1, 0, 0, A square plus BC plus 1. And then you have a negative sign here. A square, AB, AC, 1 plus BC. Now let us subtract it. A square plus BC plus 1 minus A square. A square gets cancelled. You get 1 plus BC here. Then you have 0 minus AB here. 0 minus AC is minus AC. A square plus BC plus 1 is minus 1 plus BC. BC plus 1 gets cancelled. A square it will be. So you see these two, left hand side, right hand side, are equal. So I'm just giving you the actual result. This is how you have to do it. This is the step by step you have to follow. We have so and now, LHS, RHS, hence proof. This all you have to write in an arranged and disciplined manner. That will be the answer. Now AB inverse we have to find out. Now let me show it here also, because you already know how to find out the inverse. A and B inverse is given. So we have already seen just now in previous question, there is a property that A into B inverse is equal to B inverse A inverse. Right? A and B inverse is given in the question. So AB inverse, we already saw in the earlier questions, AB inverse is equal to B inverse into A inverse. Right? Okay. Now AB inverse, we have to find out. So B inverse is already given in the question. A inverse we have to find out. So this is 3 by 3 matrix. I hope you will be able to do it because we have already done the question like this. So you have to find out the cofactor matrix here. In place of 5, you have to write the cofactor of 5. In place of 0, cofactor of 0, like this. Cofactor is nothing but you just forget the row and column where that number is and take the sign minus 1 to the power of I plus j. Now take the transpose here. And then when you take the transpose of the cofactor matrix, that is going to be the adjoint A. Determinant of A, I am not doing it, but I am telling you it's going to be minus 1, negative 1. And all the signs you are going to change because minus 1 division or multiplication, that means the sign needs to be changed. So all the signs will be changed. That is going to be your A inverse. And now since B inverse is already given in the question, A inverse you have found out, just multiply these two. You already know how to multiply two matrices. That is going to be your B inverse A inverse, and that is going to be equal to AB inverse, and that will be your final answer. B inverse A inverse is simply equal to AB inverse that you need to compute in this question. Basically, matrix multiplication is important here. Now this question is exactly similar to what we have done just now. F alpha, G beta, there is nothing different. They are just like matrix A and B. So F alpha inverse is basically, if you just assume it to be A, you have to find out A inverse. And that is going to be equal to F minus alpha. Minus alpha means in place of alpha, you just have to replace it with negative alpha and use the property or properties of trigonometry or trigonometric identities or relations. So F alpha, now when you put negative alpha in place of alpha, what do you get? So F minus alpha, in place of alpha I am putting minus alpha. You see here, this is going to be in all the three parts, 1, 2, 3. So cos minus alpha minus sine, in place of alpha write minus alpha, it is going to be 0, 0, 0, 1, sine negative alpha, cos negative alpha, 0, 0, okay. Now cos minus theta is cos theta. So cos minus alpha will be cos alpha. Sine minus theta is minus sine theta. Minus is already there outside. So you have sine theta. 0, 0, 1. Sine minus alpha is going to be minus sine alpha. Cos minus alpha is cos alpha, 0, 0. So this is going to be your F minus alpha. So when you will take the inverse of this matrix, you need to get this matrix which we just got. And I hope you'll be able to do the inverse, because inverse we have already discussed. I'll show it to you here for you to observe the result. So you will take one element, find out the cofactor of it, and then replace all the 9 values with the cofactor which you see here. So once you get the cofactor matrix, you have to transpose. So all these C11 till C33, all these values needs cofactor, and cofactor will always have the signature sign, and that sign will be minus 1 to the power I plus j. So all this value you have to put it here, and then you have to take the transpose of this. Once you take the transpose of this, that is going to be divided by the determinant. Once you find out the determinant, if you want, I can find out the determinant also. Let us see. You can open it using the third row or the third column. I am going to open it using the first row. So cos alpha, and since we already have the cofactor, you can directly replace it. Okay, it is going to be cos alpha inside. That is cos alpha 0, 0, 1. That is going to be cos alpha. And then we have minus already. So we have this. This is C12. Let us see C12 here. So you have a minus sine alpha. This was already minus become plus. So let me replace this negative with plus. So cos square, as I said, minus was there. So it will be cos square plus sine square. And sine square theta plus cos square theta is going to be 1. The determinant is 1. So divide this matrix, that is the adjoint of F alpha, divided by 1. And that will be exactly similar to this one. Okay. Now same thing you have to do for the second part. Do it for G beta. G beta is simply, you can assume it to be B matrix. And same thing, same scenarios, same logic or same way you have to do. Okay? Because cos minus alpha, remember cos minus alpha is cos alpha and sin negative alpha is going to be minus sin alpha. This you have to apply it here. Cofactor matrix we have just seen how to find out. Along with the sign, because cofactor is all about signs, minor with sign is cofactor. Then you have to take the transpose divided by the determinant. Determinant is going to be 1. The next one is f alpha into g beta. So you have to perform the multiplication here. F minus alpha, g minus beta you have already computed in the 2 parts. So you just have to multiply the f minus alpha with g minus beta. I hope you will be able to do it. Then f alpha into g beta you have to compute f alpha into g beta and take the inverse. I hope you will be able to do it. Okay, this question we'll take in the next discussion. Till then, thank you so much. Take care of yourself.